dear students. I hope you all are fine. So here I am with the lecture number 2, and in the lecture number 1, I have started that types of polymers. Here also we'll do the same thing, okay, but in on another basis. In that we have added that how many nature and we have discussed about the nature, how what will be the monomers nature, on that basis how it will be, and how they react and all that. So today we are going to divide the polymers, classify the polymers on the basis of mechanism, that how they react, okay. So in order of the first thing we are going to do, that is on the basis of mechanism involved during the polymerization. What will be the mechanism? Let's see. So addition polymer, sorry, and we know that already we have done addition polymers are such where the monomers are going to simply added. Yes, so there will be no elimination. कुछ और नहीं होगा. Simply the two or more monomers will be added with each other just because of what we say, cleavage of bond. ठीक है, bond टूटेगा पहले वाला and then new bond will be formed. In this case addition में it can be same monomer, it can be different monomer. You just be careful, this is on the basis of mechanism. Yes, it doesn't say that कि वो same ही होगा. अगर same, if all the monomer are same, then it will be called homopolymer. And in this the mechanism क्या follow होगा? If the mechanism is going to be followed by this addition वाला, तो वो क्या देगा? वो we will talk about the mechanism. Are you getting it? What I am saying? जो हमारे जो पॉलीमर्स हैं, दे आर एडिशन, कंडेंसेशन, थर्मोसेटिंग, ये वो वी हैव डन. ओके, एडिशन एंड कंडेंसेशन वी हैव डन. नाउ दिस एडिशन एंड देन वी हैव डन होमोपॉलीमर एंड देन कोपॉलीमर एंड ऑल दैट. सो होमोपॉलीमर कहने का मतलब क्या होता है कि वेयर द टू और मोर स्मॉल कंपाउंड, स्मॉल unit will be added but they should be same. Got it? यहाँ पे हम मैकेनिज्म की बात कर रहे हैं, तो वी आर नॉट गोइंग टू टॉक अबाउट वेदर दे आर सेम और दे आर डिफरेंट. इट कैन बी सेम. दिस एडिशन पॉलीमर mechanism can be addition mechanism can be in the homopolymer as well as in the copolymer. I hope it is clear. Yes, so let's see. So this should be in between multiple bonds. Why I'm saying this multiple bond? Because here it is addition, so we know that addition is possible only in case of unsaturation, because in the saturation all the bonds are already filled, so addition is not possible over there, isn't it? So in this case first one is example, that is propene. If I have given here, okay, this is propene. So how it undergoes addition kaise hoga? This bond will break on this. Let me take two molecules to be more clear. Yes, so CH3 CH double bond CH2 I'm taking. Now this is, suppose that this bond is going to break on this side, so it will create a negative charge over here and it will create a positive charge over here. Similarly this bond will shift. So if this bond shifts, so this will have negative charge and this will have positive charge. So what will be the bond form? So see, this is CH3, not going to change anywhere, and then CH. Yes, so let me write in this way. Other way if I will write, it will be easy to understand. This is CH3, CH I have written and CH3 is there. Yes. Now this CH is going to make a bond with another molecule over there. ठीक है, ऐसा कई molecules होगा. And this bond has break. यहाँ पे क्या हो गया? CH2. Now this negative is going to attach with this. So let me write that CH over here, and this CH is again further attached with the CH3 and further CH2. Did you get that? Similarly, this process is going to repeat on. So we can see that here the repeating unit is, what is the repeating unit over here? This one is the repeating unit, isn't it? Yeah. So either instead of writing this, I can write like this CH, CH3, CH2, and then just make the bond, extended bond, so that it is going to continue. Yes, and N over here. So this will be called, this was propene, so this will be called polypropene. I hope it is clear. Any doubt in this? So next, this may be addition homopolymers or addition of copolymers. As I told you, addition of homopolymers or addition of copolymers. So one example we have done. Let's do another example, more example of addition of polymers. This is butadiene, 1,3-butadiene. Yes, 1,3-butadiene. And that is acrylonitrile. So whose formula it is, like whose monomer? Buna. Yes, you say Buna. So this is Buna N, acrylon, 1,3-butadiene and acrylonitrile for this. So these are the monomers. Here they are copolymers because these are the two different monomers. Yes. So this is copolymer. Now same thing, same way we will add addition will be there. So sorry, this is triple bond. Okay, and there is no. So this bond is going to break on this side for sure. So here it will have negative charge and here it will have positive charge, isn't it? Now in this case, if this bond breaks on this side, so here it will have negative and here it will have positive charge. So resonance will occur, isn't it? So this double bond will shift over here, and now the this bond plus sign. Let me do this. Let me erase this point so that it will be clear. Okay, so if this bond is going to break, like shifting on this side, so what will happen? This will have positive charge. So now the things we have CH2 plus here, then CH double bond CH, and this is CH2 minus. On this acrylonitrile is going to attach. Yes, plus CH3 CH. Here it is plus, and here it is Cn minus. So how it will attach? Same thing. You will do that. In this case, this is CH2. Let it be. Suppose that CH2 is going to make the bond with another one. So this is CH2. Okay. Then here CH double bond CH single bond CH2, and this with this minus, this positive charge will attach. So I can write CH, and here C triple bond N, and this CH is attached with the further. So this whole is a what we say, and the bond is going to shift over here. So it will not have triple bond, it will have only double bond. Yes, and negative charge on this. So due to this negative charge, it will be bonded towards this. Again, further it will bond, make a bond. So this is going to be the repeating unit. So what we will do, we will write like this. Got it? So this is the monomer of what? Buna N. This is Buna N. This is going to repeat. Okay. So I hope it is clear. Mechanism how it undergoes addition. Yes. Other example, Buna S. Again, Buna S, we know that 1,3-butadiene and styrene, and you can do in the same way. Butyl rubber, this is also called isobutylene and isoprene. Okay, so etc. ये सारी चीजों में ऐसी तरह से addition mechanism आता है. Okay. Now the next thing, mechanism involved कैसे? Already I have explained. So here few words I have written. So let's see this. Addition polymerization, or this is also known as chain growth polymerization. Okay, why? Because the chain is going to increase, chain keep on increasing. It involves the addition of monomers by using reactive intermediate. Intermediate, we have seen that either carbocation will be formed, free radical will be formed, or carbanion will be formed. So it uses the reactive intermediate. Hence we can say that which type of cleavage it occurs? Here heterolytic cleavage occurs. Okay, such as free radical, carbocation or carbanion. For growth of polymer, in this way it increases only the length of the polymer. This is the important thing. It increases only the length of the polymer. So here we can say that ethene, this is the most common example. Ethene, when it undergoes polymerization at high pressure and high temperature, or catalyst, obviously we will put some catalyst. So what will happen? This will form like this. How? Again, do the same way. Yes, so this bond is going to break on this side. It will have minus, it will have positive. Another molecule, just take it. This is going to be here minus, here positive. What will happen? This is C, 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 and this is going to continue, isn't it? So like this. So this is monomer. Let's see the next thing. Some more information about this. Addition polymerization, that is like this is also addition polymerization over here. यहाँ पे क्या होगा? Free radical mechanism. It is initiated by the free radical mechanism. Okay, this is free radical mechanism. Process initiated by free radical has unpaired electron. इसके पास होना चाहिए unpaired electron O. So that's why it is going to break on this side attached. So this bond will break on this side. Actually क्या होगा? This bond is like homolytic cleavage. So one free electron will be there and one bond with this. So with this one free electron, it is going to make a bond over here, and OH will be there, and this free radical will remain like that, isn't it? Now, when this one is going to react with this, so this is ethylene glycol, it forms, okay? So ethylene here, what is happening here? This is going to attack on this. So again, what will happen? This will bond. This bond is like homolytic cleavage, one. So with this one free radical, this will attach, and one free radical will leave on. So again, the continuation. And this one is the repeating unit. Yes. Free radical attacks double bond to form a new free radical. Termination of the reaction occurs when two radical reacts to form a bond. So these are also another type of polymerization, addition polymerization only. Now next type, that is condensation polymers. What is this condensation? Addition में क्या होगा? Simply monomers will attach to each other. While in the condensation, uh, due to the addition, there will be some elimination of a small molecules like ammonia or CO2 or water. Okay, so there will be small molecules elimination will be there. Polymers are formed by repeated condensation reaction between two bifunctional. They must have bifunctional or at least bifunctional or trifunctional. मतलब at least bifunctional होने चाहिए, दो functional group होने चाहिए. Monomers unit usually with the elimination of small molecules like water, alcohol, ammonia, etc. So यहाँ पे आपको ध्यान देना है. There must be bifunctional. Okay, होना जरूरी है. Let's see an example. If we'll see that I'm taking an example of nylon 6,6. This is, let me take the nylon 6,6. So nylon 6,6 is what? Monomers are hexamethylene diamine. Monomers जो है, that is hexamethylene diamine and caprylic acid. Okay, this is NH2, CH2 whole 6, and then NH2, and this is COOH, CH2 whole 4, and then COH. So how they react? These are the monomers. Okay, so how they react? Let's see. Like this is NHH. And here this. So again, this will continue in this way, this will continue in this way. So between two molecules, let me see. What will happen? This NH water will come out and it will form a compound. Like again, H of this, can I remove? This is going to continuation. Yes. NH2, from NH2 one hydrogen will be there, and from COH one OH will come out. So can I write like this, NH, or in this way also I can write. This is NH and here continuation. Okay, got it. And then this is CH2 whole 6, and then what happened? Then NH, and here C double bond O, and then CH2 whole 4, and now this is CO. Can I write like this? Yes. So this is N. This is a repeating unit of what? Nylon 6,6. Clear, bachche? Any doubt in this? So this is the example of like we can say that if on the basis of monomers, if I will say which type of polymer it is, because two different types of monomer are using, so we can say that the copolymer. Yes, this is copolymer, and along with this water molecule is coming out, N molecule. And what is this N का formula क्या होगा? Let me, this is not exactly H2O. We will say that complete जितने भी molecules होंगे, whatever the number of molecules we are using, okay, like N molecules of this or N molecules of this I am using. So this will form 2N minus 1 water molecules will come out. Sometime it can be asked that how many, if I am using the same 7 moles of hexamethylene diamine and caproic acid, then what moles of water will form out? So you will solve this calculation karoge, and if you learn, you can learn this formula, so easily you can say that how many water molecule it will come out. Yes, I hope it is clear. Any doubt? So copolymer on the basis of number of polymers, monomers, and condensation on the basis of mechanism. What is the mechanism involved? Let's see again. This is also step growth. You can see that the step increase हो रहा है. It involves addition of two different monomers, I said, due to which it is also called copolymer. Yes, it cannot be present like यहाँ पे क्या होगा, homopolymer में possible नहीं होगा ये. It might be bifunctional or trifunctional, कुछ भी हो सकता है, monofunctional भी हो सकता है. Yes, by elimination of small molecules. both the monomers, यहाँ पे एक point है, this is the, if both the monomers are monofunctional, अगर दोनों monofunctional होंगे तो reaction जो होगा वो one step में stop हो जाएगा. Reaction will stop in one step only. Example, we can say that the acetic acid and ethyl alcohol, ethyl acetate and water. We all know that this reaction. Yes, I don't think so. Okay, let me do it. Yes, and this is ethyl alcohol, so I can write like this. And what will happen? This is going to form, and here it will CH3, COO, C2H5. So this will continue. If monomer is monofunctional, one monomer is monofunctional while another is bifunctional. अगर दोनों monofunctional तो one step, और अगर one monofunctional or another is bifunctional, then it will end in two steps. Yes. And if both the monomers are bifunctional, it goes in a series condensation in a stepwise manner and hence known as step growth polymerization. So let's see this one example. इसका अगर हम करते हैं, like one I am taking. Say let's take an example, like I'm taking CH3COOH acetic acid and ethylene glycol. So here it is having what? This is bifunction and this is monofunction. So how it will stop? The reaction will be in two steps. So first step में क्या होगा? This will give you HOH will come out and it will form CH3COO and then CH2CH2OH. Again, what will happen in the next step? Plus water molecules obviously will come out, and the next step again. Now this molecule will react with CH3 because OH is there, so it is going to continuation. Yes, in continuation. This is CO functional. Actually, terminals for functional group, so that will continue. Okay. So this is OH, and then next water molecule like acetic acid will continue with this. So can I write like this is COH, yes, and here it is CH3. So what will happen? This H and this OH will come out, and now it will form. You can see diester will be formed, isn't it? This is O, CO, CH3. So ester functional group are coming here. Yes, got it? So दो step में जाके end होगा. Now it is not going to it will not react. Further reaction करने के लिए कुछ है ही नहीं central because it is in the mid one, so it will not react further. और अगर if दोनों bifunctional होंगे, तो it will undergoes in a series. बहुत ज़्यादा reactions होंगे, stepwise होता जाएगा, और that is also called step like a step growth polymerization. Got it? Mechanism diacid diamine. This is diacid. If I am taking that in those COH group and diamine. One important thing I'm going to tell you, this condensation polymers is going to be of two types. One is polyamide and another is polyester. If you see the previous example in this, so this is two condensation polymers, and here it is, what is the bond? This CONH bond. This bond is called amide bond. Yes. So इसमें क्या होगा? So many amides will be formed. Amide bond will be formed. So this is called polyamide compound. So nylon 66 is which type of condensation polymers? Polyamide. So sometime it will be asked, write some example of polyamide condensation polymers. So you have to write like this, that C double bond O NH bond is going to form. Oh, sorry, I have written here caproic acid. This is not caproic acid. This will be adipic acid. Caproic acid is hexanoic acid. Okay. This is hexanoic acid. Sorry, what I was adipic acid. Okay. So this is adipic acid. Now next, like in this equation, in this example, you see what is forming. Which this is ester is forming. So this is ester. Ester. That means you can say that this is going to form polyester. Yes. So wherever acid and amine will react, it will form amide. But if acid and alcohol will react, it will form ester. Got it? So here the two type, one is condensation polymer, like polyamide, another is polyester. If acid and amines are there, then polyamide. If acids and all are there, alcohol are there, it will form alcohol, polyester. Example जो है that is polyamide का nylon, or you can say nylon 6,6. This is nylon 6,6 actually. Here it is nylon 6,6. Okay. This is sterylene, which is also known as Dacron, where we use diacid and diol, ethylene diol and acetic, diacetic acid. Now, so know some important condensation polymers. In this polyamides, which I have already explained, and here we will do few examples, extra examples. Nylon 6s, which we have already done. Adipic acid and hexamethylene diamine will be the monomer. Okay. This is sorry, this will be 6, and here it is again NH2. So what will happen? This is going to form, yes, continuation. So similarly, this will happen, this will go. So this, what left with this CO, here we can say that it is going to continuation, and then CH2 whole 4, and then CO NH. This is amide bond, yes, and then CH2 whole 6 NH. That is going to repeat. So this is amide bond, so it is called what? Amide, polyamide. Another is nylon 610. Monomer is hexamethylene diamine and sebacic acid. Okay, sebacic acid may there will be the same thing. It will be only this instead of the CH2, it will be 8. Okay, so we'll do in that way. NH2, CH2, NH2, and then here we will form CH2 whole 8, and then CH. Sorry, this is okay. Again the same thing, it will happen. HOH, and here it like this. So this is NH, CH2, NH. I can continue with this. And then what will happen? Here it is CO, CH2 whole 8, and then CO. So this is nylon 610. Monomers are hexamethylene diamine and sebacic acid. Okay. What are the uses of these polyamides? They are having very high tensile strength. They are tough, resistant, and elastic. That's why used in textile fibers, carpets, bristles of brushes वगैरह में इनका use किया जाता है. Next examples, other example nylon 6, or which is also known as Perlon. This is Perlon. Okay, made up of single monomer. यहाँ पे single monomer होता है, but वो bifunction होता है. So like caprolactam. The nylon 6 monomer is caprolactam, and actually caprolactam कैसे बनता है? Whenever it is asked that what is the monomer of nylon 6, you are supposed to say caprolactam. Okay, and caprolactam formula will be what? This is NH 7-membered ring, amide ring it is. 2 I have made, then 1, 2, 3, 1, 2, 3, 4, 5, 6, and this is 7. Got it? 7-membered. So how it forms? Actually, this is formed when this is caprolactam. This is caprolactam. Okay. So ये कैसे बनता है? This forms by the 6-amino-hexanoic acid, or which is also known as 6-amino-caproic acid. Caproic acid is actually hexanoic acid. Okay. Caproic acid और hexanoic acid same चीज होते हैं. तो ये इसका जब हम ये देखते हैं तो what happens जब हम इसे heat करते हैं तो this is 533 Kelvin to 543 Kelvin. Temperature can change. So what will happen in this? Sorry, this reaction will be like this, opposite direction. So this is 6-amino-caproic acid, 6-amino-hexanoic acid I said. So this is NH, okay, and this is CH2, 5 members it will be, and then hexanoic acid. So I am writing hexanoic acid in this way. Any doubt? Clear? So what will happen when we heat this? So water will come out, and this will again form, and later on it will form this compound. So let's see कैसे बनता है ये NH, and then 5 CH2. So 1 CH2, 2 CH2, 3, 4, 5. Okay, and then C. So this is CO. Same. It's a mirror image. You can say समझ में आ गई बात? तो दिस इज कैप्रोलैक्टम और ये कैसे बनता है? ये दिस इज 6 amino hexanoic acid, or somewhere you can see that this is written as like this 6 amino caproic acid. Both are same thing. Okay, I hope it is clear. This is used in tire cords, fabric and mountering के लिए जो ये ropes वगैरह जो use होते हैं, so with there it is used. Okay. Next part is polyester. Polyester क्या होता है? There will be obviously the acid and the base will is going to combine. So example जो है वो terylene and dacron. This is one of the very toughest or very tough fiber they are. So in this, let's do some example. Terylene or dacron. The monomer is ethylene glycol. Monomer जो होगा इसका monomer is ethylene glycol and terephthalic acid. I've told you ethylene glycol is like this, CH2, CH2, and here it is OH, OH, and terephthalic acid is this, COH, COH. Got it? So they combine with each other and then they form. So this is ethylene glycol and this is dimethylene terephthalate. यहाँ पे ये HH it is showing that how it reacts later on कैसे react हो जाएगा. तो पहले ये क्या हो रहा है, अगर हम basic structure देखें तो first it will be, this is H, okay, so H and OH will come out and this will form dimethyl terephthalate, and then this dimethyl terephthalate will further react with ethylene glycol and then it will give you the repeating unit of this, that is called polyester. I hope it is clear. Any doubt in this? Yes? Clear? Okay, now let's see, you can write in that way also. Next, phenol formaldehyde resin. It is again one of the important resin over there. Oldest polymer obtained by condensation of phenol with formaldehyde in presence of either an acid or a base catalyst. Acid or base catalyst के presence में होगा ये reaction. Okay. So how it is when there's phenol and formaldehyde? Phenol is like this. Later on I have done this mechanism is given over there, so I'm not going to show much. In presence of base it will react and this will first form Navolac, OH, and CH2OH will form. Okay, ortho and para, OH and CH2 will form. How it will form? See, this bond is going to break on this side, yes, and then ortho position here, this H being better leaving group यहाँ से हटके आ जाएगा OH के साथ, and this is due to plus charge ये जाके यहाँ पे attach हो जाएगा. So this is similarly it can do the para position. I hope it is clear. And when this Navolac, ये जो चीजें जो monomers हैं, when they undergoes polymerization, both type like ortho and para दोनों, so there will be cross and linear polymerization both occurs. So when they react, they undergo polymerization at very high temperature, so they will form Navolac. Okay, and Navolac formula will be like this, OH, and here it is CH2, and then this is, no need to learn this mechanism and all, you just have to learn only the formula, only the monomers. Okay, but if you want you can do it by your own, there is no problem at all. And this is going to form, this is Navolac, and when this Navolac undergoes cross polymerization it will form bakelite. So that I have done later on. Okay, this is Navolac, this is the monomer of like when this combination of formaldehyde and with phenol. Navolac on further heating with formaldehyde undergoes cross linkage to form an infusible solid known as bakelite. Got it? And these are the bakelite is that substance which we have seen in switch boards and that handles of your pressure cooker in the kitchen and all that. Yes. So this is the mechanism. No need, again I am telling you, no need to learn this mechanism. This is just to okay कि हाँ you know what is that, how it occurs, वो चीजें मैंने लिखी हुई, but आपको mechanism learn करने की जरूरत नहीं है. Uses used as binding glue, manufacturing combs, tabletop, fountain pen, barrels, computer disk, switches, plugs, handle of utensils, etc. So most common use ये रहा, handle of utensils, switches, plugs, which we have already used so many times. I have used. Yes. Next, melamine and formaldehyde polymer. This is melamine. Okay, you have seen that utensils of melamine, unbreakable जो होते हैं. Melamine and formaldehyde undergo condensation and also called melamac. So if someone asks the monomer of melamine formaldehyde, either you can say that the melamine and formaldehyde, or you can say melamac. Got it? This is melamine. Melamine formula is like this. This is first nitrogen, second nitrogen, and third nitrogen. Benzene ring में 3 nitrogen and 3 carbon, and all these carbon are attached with the NH2 group. So this is called melamine. समझ में आई बात? There is C3, C6H6 is benzene. Benzene, yes. What you will do? You will say that C3H3N3. ये बन जाएगा. Carbon divide हो जाएगा. Got it? And then all the carbon, with all carbon, this NH2 group will be attached. So that is called melamine. Formaldehyde, it will form the intermediate, and this undergoes polymerization to form melamine. You can say this is a melamac. Okay, and this will form polymer. Uses widely used for making non-breakable plastic crockeries. Yes. Next is copolymerization. When two or more different monomers are allowed to polymerize together, their product are known as copolymer. We know that. Example: Buna N, nylon 6, etc. One example there I have the Buna N. We have done here. It is Buna S. The unit जो है 1,3-butadiene, and this is styrene. You have to learn the monomers. Yes. Buna S is very tough and it is good substitute of natural rubber. Natural rubber जो होता है वो बहुत soft होता है, तो उसका substitute होता है Buna S. Next topic is rubber, which we will do in next video, and that will be the last topic. So I think this chapter will be finished in third video. So till then, thank you class. Learn the chapter properly. Learn all the monomers. Write together all the monomers जो भी हैं सारे एक साथ लिख के you learn it, because in this chapter the most important question is that define monomer. What are the monomers and some definitions like this. Yes. Okay class. So thank you. We'll meet in next video.